An international team of researchers using computer simulation has found that about 4.5 billion years ago, at an early stage in the formation of the Earth, it might not be as round as we know it. The study, which National Geographic talks about, may delight adherents of the theory of flat Earth. The authors of the work prove that our planet did not always have such a round shape as it is now. In ancient times, it could look like a potato, rugby ball or frisbee, a famous plastic flying disc in the shape of a saucer. This unusual form could be related to the fast rotation speed of our planet and the proximity of the young moon to it. The generally accepted theory is that about 4.5 billion years ago, the Earth collided with a large object. As a result of this disaster, part of the material of our planet was torn out. According to the new model, the young satellite of our planet at that time was so close to the Earth that it had a very strong and strange effect on it. According to researchers, the Moon at this stage was 30 times closer to us than it is now. The calculations showed that this proximity could disturb the balance between the Earth and the orbital motion of the Moon. This made our planet spin so fast that it literally stretched out. It was then, according to the authors of the work, that the Earth woke up from hibernation. Volcanic activity intensified on the planet, the process of dramatic mountain building began and the landscape began to form. In the first tens of millions of years of Earth's history, it was an incredibly dynamic place, said co-author Simon Locke of the California Institute of Technology. It was a completely different world than people imagine. An article by researchers has not yet been peer-reviewed, but this idea already has both proponents and opponents. For example, Sarah Russell, a professor of planetary science at the Museum of Natural History in London, who did not take part in the study, stated that the idea of an elongated Earth sounds strange. Nevertheless, it is possible that the young moon could indeed play the role of its first geologist. Locke and his colleagues believe that about 4.4 billion years old zircons recently found in Australia speak in favor of their theory. These minerals are usually found in chemically complex rocks such as granites. A geologically weak Earth could not have created them. But if the young moon launched geological processes on the planet, then zircons could well have formed 4.4 billion years ago. In addition, it is known that the Earth and the Moon are inextricably linked with each other by gravitational influence. The laws of physics suggest that if one object changes its behavior, then another changes it in order to maintain equilibrium. This principle formed the basis of the simulation. The simulation showed that the Earth should rotate faster when the Moon is nearby. Now the distance between these objects is about 384,000 kilometers. Scientists have suggested that 4.5 billion years ago, the distance could be only 12.5 thousand kilometers. With such an indicator, the speed of rotation of our planet would be such that the day would last on it only 2.5 hours. It was a time when a crust in the ocean of molten magma had just formed on Earth. High rotational speed suggests that our planet could experience spherical deformation and turn into something much more elliptical. I never thought that the early Earth could be so flat, says Robert Stern of the University of Texas at Dallas. It may sound crazy, but the theory put forward makes sense.